Nearly 2,500 years ago, there lived an ancient Greek philosopher by the name of Democritus. Democritus had a very unique idea about the world that many seem to resonate with. This idea was that everything was made of very small particles that were as small as anything could be and could not be cut. He called these particles atomos, which is where we get the modern-day word, atom.
Centuries later, an English chemist by the name of John Dalton expanded on Democritus's idea with several new stipulations. Elements are made of extremely small particles called atoms. Atoms of a given element are identical in size, mass, and other properties. Atoms of different elements differ in size, mass, and other properties. Atoms cannot be subdivided, created, or destroyed. Atoms of different elements combine in simple whole number ratios to form chemical compounds. In chemical reactions, atoms are combined, separated, or rearranged. These ideas form the basis of Dalton's atomic theory.
In the late 1800s, J.J. Thomson was doing experiments on cathode rays, what we now know as electron beams, when he noticed that cathode rays traveled through air much faster than something the size of an atom. In fact, it would have to be at least 1,000 times smaller than a hydrogen atom. This would lead him to come up with the idea for the electron, a negatively charged particle with a very small mass. With the introduction of the electron, the atomic model had to be revised to include it, which resulted in the plum pudding model, the idea that electrons float around in a pudding that is the bulk of the atom's mass.
With those ideas in mind, Ernest Rutherford began his experiments with atoms and atomic theory. The most famous of these experiments is the gold foil experiment. This involved shooting a neutron beam at a thin sheet of gold foil. Rutherford noticed that most, but not all, of the neutrons went straight through, essentially proving the existence of a small object in the middle of the atom that he named the nucleus. Later, he would revise this idea by adding neutrons and protons to his theory, creating the Rutherford model of the atom, which later became the Rutherford-Bohr model that still plays a part in atomic modeling today.
For a final overview of what the atom is, it's the smallest particle of an element before separating begins to change the qualities of the material. The current model of the atom has 3 particles that constitute different properties of individual atoms. Number 1, the proton. The proton is a positively charged particle with a mass of 1 AMU. It is also what defines an element as being that element. The other 2 particles can change from atom to atom, but if the proton count changes, then it's no longer the same element.
Number 2, the neutron. The number of neutrons can change from atom to atom, creating different isotopes. Its major purpose in most atoms is to create space between protons within the nucleus. This is due to the fact that all protons are positively charged and naturally don't want to be near each other. However, the neutron allows them to have space, creating stable atoms. The neutron is a neutrally charged particle, which, like a proton, has a mass of 1 AMU.
And finally, my personal favorite particle, the electron. The electron has a negative charge, but such a small mass that we approximate it to 0 when doing calculations. The electron is what decides reactivity, and it does this through the outermost collection of electrons known as the valence shell. All atoms are chemically stable at 8 valence electrons, so when an atom with 2 valence electrons and an atom with 6 valence electrons meet, they form a chemical bond, sharing each other's electrons, allowing them both to have 8.
In conclusion, the idea of the atom has changed many times to become what it is today. We went from them being a single object to having 2 parts to having 3 parts, and there being mostly empty space. We've come a long way in our understanding of the atom, and we're still learning more and more about it to this day.
Thanks for watching.